understand what are those current, what are the components of those current that we are measuring, and what is the important part that we need to measure. And also, uh, because I want to compare the polarization index with the spot reading test, so we'll be discussing shortly about the spot reading test. And so we go to the main topic, the polarization index and then the electric absorption ratio. So I will be giving also an example of a test and how to analyze them. So to review first, basically this insulation testing or this DC insulation testing is basically from the Ohm's law. And we all know that the voltage is equals to current times the resistance. And since we are getting the insulation resistance, so we have the R here is equals to voltage divided by the current. So we know that the resistance is directly proportional to voltage and inversely proportional to the current. So meaning if I want to measure higher resistance, because that is directly proportional to voltage, so I need a higher voltage. And during measurement, if I got a high current, meaning I will have a low, please take note of that. So in ideal world, there is a perfect insulation. No insulation is perfect, and no insulation has infinite resistance. We have some electricity flow or leak along the insulation through the ground, and such current may only be a millionth of an ampere or 1 microamp. It's a very small magnitude of current because it's just a leak. And this leakage current is the basis for the insulation testing equipment. This is what we are looking for. This leakage current will define how our insulation is doing, how good is our insulation. And when we say good insulation, that means we have a relatively high resistance. And by describing an insulating material good, that means that insulation has the ability to keep a high resistance no matter how much voltage you injected, no matter how much voltage it experienced or has. So the ability of keeping its high resistance is a quality of a good insulating material. But over time, we cannot avoid these enemies of insulation. Insulations are not the things that we install and forget. We have so many enemies for insulation. You have the mechanical damage, you have the vibration, you have the excessive heat or cold, you have the dirt or oil, you have corrosive vapors, you have moistures from processes, and even the humidity on a muggy day. It will make our insulation bad. And over time, all insulation will fail because of the mechanical stress, electrical stress, and even the pollution in the environmental stress. If we don't detect this deterioration, what will happen? Of course, it will increase the possibility of electrical shock, or worse, death of a personnel. Also, it increased in the possibility of electrically induced fires. And of course, the expected lifetime of your equipment will be lessened. It will reduce the age. It will increase the aging of your equipment if you don't detect this deterioration. And the most costly things that will happen is the unscheduled downtime. So when we say good insulation, again, we are talking of high resistance, and when we say poor insulation, that is a relatively low resistance. And actual resistance values can vary higher or lower depending on the factors such as temperature and the moisture content of the insulation. We know that temperature can affect the insulation. The resistance of insulating material decreases markedly with an increase in temperature. And one rule of thumb is for every 10 degrees Celsius increase in temperature, it will halve the resistance. Or for every 10 degree decrease in temperature, that will double the resistance. Please take note of that. So to make reliable comparison between readings, because the best way for you to analyze the results of the insulation resistance is to do historical trending, meaning you compare test 1 to test 2, which happened at different times, of course, and then you do the plotting, or you plot the curve, see what is happening, and of course the ideal is it should be identical or flat curve. But if something happened between times, for example, it drops down substantially, then that means you have, it may be a result of something catastrophic, something bad. So in order for you to have this trending, you need to have a uniform base. That's why you need to correct each reading to 20 degrees Celsius. You need to have a base at 20 degrees Celsius. If you're going to compare things, you need to have a base, and that base for this insulation resistance is the 20 degrees Celsius. So that is how you do the interpretation of the spot reading test. So each time of insulating material will have a different degree of resistance change with temperature. And factors have been developed to simplify the correction of resistance values, that is the temperature correction factor tables, which is available for different types of apparatus and types of insulating material. And since this is a review, actually you can have more details about it when you review the other webinars regarding the insulation that was conducted by, or that were conducted by Jeff Johet. And also there are some materials like the stitch in time and the 1 kb DC insulation testing. And those are the application notes that will give you more information about the effect of this temperature. So when doing the insulation test, it could be go or no go, meaning if you found out that the insulation has contamination, if it has a fatal installation or maintenance error and it has a serious degradation, then you can decide right away if you could put it back in service or not. You can also do diagnostic tests. And this diagnostic test will give you more information from the response of the insulation. So for me, I guess better to do if for example your insulation passed the go or no go test, then you do the diagnostic test for better view or for better information of the condition of your insulation. So why we do this diagnostic insulation testing? Of course, it is a trend towards predictive. We are looking forward what will happen with regards to your insulation. So meaning we can predict if we are going to do maintenance work, if we are going to do a testing, and by that, it will lessen the fixed maintenance interval, the fixed time for maintenance interval. Because when we do predictive maintenance, then we are looking at the actual condition of your insulation, and by doing so, you can predict your, the future, or you can predict ahead of time what will happen. So remember, for an effective maintenance program, if you test periodically under the same condition, you do keep records of the test for comparison. So test periodically under the same condition, that is number one, and you keep the records of example. For example, this is a cable, and the positive on the outside sheet of the cable or the shield of the cable. here. And the purpose of this guard from the computation. So that will on the webinar that we had for the terminal, for the guard terminal. And these are some recommended test voltage per equipment rating. So in this table here, you can see up to 100 volts, then that recommendation there, you will hear some sounds from that insulation if you injected more test voltage. And according to the NETA standard, we have this latest table, the table 100.1, wherein on the leftmost column, no rating of the equipment volt need to correct it into 20 degrees Celsius, for example. Then we can record and factor relative humidity, of course. And we must do it same time interval for spot reading test. If we're going to do the spot reading test, then we need to do it in an interval with time interval. Now, let's go to the components of the current that is measured. So the total current is the sum of these three components. Number one is the capacitive charging current. So this capacitive charging current happens in the first few seconds. So it's very fast because we treat insulation as capacitor because we have insulation or conductor, two conductors, and in between of them we have this dielectric, and so we treat it as capacitor. So this capacitance charging current happens rapidly. It happens to charge the capacitance, and so we call it capacitance charging current. And we also have this absorption current or the polarization current. So this absorption current is during the time when the molecules or the dipoles or the electrons are aligning. So they are moving. And the most important of these three components is the conduction or the leakage current. Again, this is what we are looking for. This what will happen? What do you think? Because this AC voltage is oscillating, of course, what will happen? These electrons will move also. Constant moving, but they are moving, but not in a constant direction. And of course, the dipole or twist, something like this, will be attracted to positive. So it will go to the left-hand side. And when that happens, we call it capacitive charging current because those electrons are moving. So when we define current, that is a moving electron. So when it moves towards the positive side, so that's the time when we have this capacitive charging current. And again, it happens in the first few seconds of its large system. Of course, it will happen in a minute, for example. And if these dipoles will be aligned or realigned, something like this, see the negative towards the positive side, and then the positive charge towards the negative side, then that's what we call polarization. It became polarized. So it happens. Also, the same time with the capacitive charging current, but it will take longer than the capacitive charging current. So also, the conduction current, if your insulation is if we want to measure purely the leakage current. But sometimes if we have the insulation, then we can have a surface leakage current. So we have additional current here. And we all know that if we have a guard terminal, that could be eliminated. That could be nulled, something like that, with the computation of the total resistance by using the guard terminal. Okay, so that is happening. So when we look at the magnitude over time graph, so we have y-axis as the magnitude of the current and x-axis as the time. So when we have this capacitive charging current happens, so you can see here, in a short period of time, but in a high magnitude, there is a current, what we call capacitive charging current. And at the same time, if these dipoles aligned, we call it absorption or polarization current. So it's a little less than the capacitive charging, but it happens longer than the capacitive charging current. And when we have this conduction current, because of the deteriorated insulation, so as you can see here, there's no end for the conduction current. It will be forever as long as you have this deteriorated insulation. So over time, it will be infinite. See here? So you have a moving electron, then you have a conduction current. And if you have contamination and you miss to clean it, still dirty, for example, you remain it dirty, then you have the surface leakage. So adding up the capacitive current and the absorption current, then you have this purple line here, the total current for the capacitive and absorption current. And if you add up, but remember the capacitive charging will only happen on the in the first maybe 1 minute, and the only current that will remain is the leakage current or the conduction. So if you have contamination, of course, your current will be a little higher if you have contamination. Okay. So in summary, again, what we're looking is this conduction leakage current. So when we do the we let this capacitance charging happen first. We let it or when they are something like saturated, for example, then you will have the pure leakage current. That is what we're looking for when we do the polarization. So insulation resistance readings, please take note that readings are time dependent. So a test starts when you start the test, you have the capacitive current in the first second. Current is a combination of polarization and leakage current. And after 10 minutes, reading is mainly leakage current. Please take note also that current is temperature dependent. These are the selected test apparatus, for example. So examples of low capacitance devices are the high voltage buses, you have the switch gears, you have the short cable runs, and you also have the small motors. An example of high capacitance devices, you have the large generator, you have the long cable runs, and the large motors. Resistance test. The most popular one is the spot reading test. This is the test of the 60-second as you are familiar with. So we inject the DC voltage for 60 seconds and get the result. Also, this time resistance method is when we do the comparison over time. But of course, this presentation, we will be dealing more of the dielectric absorption ratio, and which is also called the polarization index. So just depends on the time domain. And we have this multi-voltage or step voltage test and the ramp voltage test. So these two, the multi-voltage or step voltage test and the ramp voltage test, are somewhat the same, because these tests are based on the principle that whatever voltage you injected, of course, the resistance should be identical or the same. So for example, it happens that in a certain test voltage, your resistance reading got so much low, then that means that insulation is having a problem or a voltage dependent. Okay? But again, like I've said, we will be talking more of the dielectric absorption ratio. And if you have our MIT or Megger insulation tester or the S1, then these are the dielectric absorption ratio and the polarization index. So the good thing with our equipment is that if you get this PI, then you can already have the dielectric absorption ratio. So the spot reading tests are these test modes here, the IR and the IRT. So normally what we are doing is we inject voltage for 60 seconds, and then we get this value at the 60 second. So with the spot reading test, so a good test for apparatus with very small capacitance. This is good for apparatus with very small capacitance. And only a rough guide how good or bad your insulation is for capacitive equipment for first test. And for analysis of the spot reading test, you need to do the trending. So analysis of periodically recorded readings provide a better analysis for judging insulation condition. So yeah, that is the better way to analyze the spot reading test. Because the spot reading test is only happening at 60 seconds. So meaning you need to compare that on the previous test result, because it should, it's just like this. It should have the same reaction, because of course, if you test the same equipment, it should have the same capacitive charging current time. It should have the same absorption current. So you need to compare, okay? Because with the spot readings test, we are not sure yet if we already don't have that capacitive charging and absorption current. That's why we need to compare with the same or with the previous test result. So time resistance method or polarization index and the electric absorption. What is it? Right? So PI and DAR are fairly independent of temperature and can give conclusive information without records of the past test. Meaning you don't have to trend this. You don't need the historical data. This is diagnostic insulation testing. And it is based on the absorption effect of good insulation compared to that of moist or contaminated insulation. When you have a good insulation, it will show a continual increase in resistance over time, 5 to 10 minutes. Okay. And these are the tests, the DAR and the PI. So with the polarization index, this is the ratio of 10-minute reading over the 1-minute reading. So it is the simplest implementation of the time resistance test for solid insulation, and the result is a pure number and can normally be considered independent of temperature, since the thermal mass of the equipment being tested is usually so great that the overall cooling will take place during the 10 minutes of the test is negligible. So that means even if you injected voltage for 10 minutes, the temperature is not changing or is negligible. That temperature change is negligible. For example, I inject now, and then I waited for 10 minutes. Oh, the equipment is not cooling down. Okay? So it's independent of temperature test. When there is no so much change in temperature, that is applicable. Okay? And with the DAR, for the dielectric absorption ratio, we are getting the 60-second value divided by the 30-second value. So if your insulation is good, like I've said, it is a continual increase in reading, in continual increase in resistance, if it is good. And if, for example, it has moisture or contamination, then it could be something like this or a flat curve after 60 seconds. It is also the simplest because it's also called as the polarization index. And the ratio of the two time resistance readings such as 60-second reading divided by the 30-second reading. And for the assessment, so you can refer to this table here. So for the DAR, it is excellent if you got a number of 1.6 and above. It is good if it is 1.4 to 1.6, then it is questionable if it is 1 to 1.25. Okay. So looking at the example here, let's take a look at the polarization index of a good insulation. So here in my example, I got 10 mega ohm at 1 minute value. And after 10 minutes, I got a 50 minute mega ohm. So meaning my resistance increased. So according to PI, that is 10 minutes over 1 minute, then I have a ratio of 5. And so when I refer it to the table, that means my insulation above 4. If you get above 4, then that means your insulation is good. Okay? But you may ask me, why good? How come? Right? I know you will ask that. Now let's go back to my previous slides in discussion. Again, we have 3 components for current. We have the capacitance charging current, we have the absorption current, and we have the conduction or the leakage current. So again, looking at this insulation here, when we applied AC, then the molecule will move, then you have current. And you don't know where it goes because it's AC, it's oscillating. But when you apply the DC, then you can have the capacitive charging, you can have the absorption current, and you have the conduction current. But again, if you have a surface leakage, then you can have contamination, or you have contamination, then you will have this current or contamination or the surface leakage current. Now, again, looking at the time diagram, we have the magnitude over time diagram. Capacitive charging current happens on the first few seconds, as you can see here. And the absorption current will happen maybe longer than the capacitive current, but it goes down over time because that's the time when these dipoles aligned already. And you have the conduction current, and you have the contamination current or the surface leakage current. And the total current, when you add up that, adding the conduction current, you have this total current in the purple line here. See here, at this period of time, I got a leveled current, meaning I will only have a pure leakage current. This current from the capacitive charging and this current from the absorption current is no longer is no longer available in my reading. I am only reading after 10 minutes my leakage current. And of course, when the equipment is in service, that's the real thing. That's what will happen. And if you have contamination with your insulation, then this current will be a little bit higher. Okay? So meaning, this result here, when I have a small current, that is a good insulation because I don't have any contamination. But again, I have a leakage current, which may be a little bit, the total current here. Because these two, the conductor current and the surface leakage current will add up. That's why I have a higher current here. And again, after 10 minutes here, I got a leveled current. No more effect from the charging current, no more effect from the absorption current. That's why I need this 10 minutes for my polarization index. So this is my summary again of the component of the currents. So that's the answer. How come? Why is it good? Because number one, it is more than 5. And according to the table, it is good. Okay, so why good and how come? The answer is because at the start of the test, I have capacitive current, which I seen in the first second. And at 1 minute, current is a combination of polarization and leakage current. And after 10 minutes, reading is mainly leakage current. So at first, 1 minute, I got more current. So again, when we go back to the Ohm's law, if I have more current, I have less resistance, right? So more current, less resistance. But after 10 minutes, because I don't have the capacitive charging current, I don't have the absorption current, then that means I have less current, and that less current will give me high resistance value. But if, for example, I have moisture and dirt, this is an example of the questionable insulation then. So 10 minutes over 1 minute, I just got 2, ratio of 2. That's why if I have 2, then the result is questionable. Meaning to say, if it is questionable, then I have to do more. I have to do another test. Maybe you can do tan delta test. Maybe you can do insulation power factor test, or you can do AC, or you can do the electric discharge test. So in this example, this is questionable. And how come? Again, at first I have capacitive, and after 10 minutes that is gone. At second or at 1 minute, current is combination of polarization and leakage current. And at 10 minutes, supposedly, I am expecting that is only a leakage current. However, I have contamination. I have dirt. That's why I still got a low resistance reading after 10 minutes. That's why this example here or this graph here will shows that my insulation is questionable. Okay? So meaning I got more current, and when I have movement of electron, that's constitute a current. So if you have moisture, you have a lot of movement of electrons. So why we do this test? A summary of my presentation. So time resistance method, this is if you want diagnostic testing. This PI and DAR is a must if you don't have past test result or historical data. Or if you have large system that a change in temperature is impossible, meaning not impossible, but it's negligible, or the change in temperature over 10-minute period time is negligible. So you can do this polarization index test. And if you want to measure just purely leakage current, so if you want to consider just purely leakage current, then you must do, or you do this PI or DAR. Okay? So that brings me to the end of this presentation. So if you have any questions, sir, you can type in the chat box and we'll answer it for you. So thank you so much for listening. And again, if you go to our website, you can see this guide, a guide to diagnostic insulation testing above 1 kV. And all I said, you can read it from here. Okay. So now let's go on to the question and answer.
Okay, thank you, Michael. Here we got 3 questions in the questions panel. So 4 questions. Okay, I will start from the first one. Why is insulation won't have capacitive charging when AC is applied?
No. Maybe he misunderstood. There will be capacitive charging also when AC is applied, but that will be very, very fast. It will happen very, very fast. And so in my illustration during the presentation, that is only just an illustration. But of course, when an AC is applied, you will have a capacitive charging as well. But that happens in a rapid way. So that could be charged immediately. And we know why when you have this AC applied in for example, in a motor, and you have a problem in a power quality, that capacitive charging could be discharged in a much higher voltage. So it happens with the AC insulation, with the AC voltage also.
Okay. I think he also has a follow-up question. Does it mean that insulation is DC capacitor?
Yeah, that is a capacitor, not just a DC, but also AC-DC capacitor.
Okay, thank you for the question and answer. The third question is, if PI test fails and IR test pass, does it mean that it's safe to run the equipment?
Okay, so maybe he is referring to the spot reading test over the PI. So again, when we do the spot reading test, we do the 60-second, right? And if it passes, I don't think it will fail in the PI test. I don't see it will fail on the PI test because it's already passed at the spot reading test. And with the spot reading test, by the way, you need to have historical data for that. But yeah, in the past webinars, we have discussed some rule of thumb, which is for the spot reading test, 1 kV is equals to 1 mega ohm plus 1. So you can also use that as guide. Okay. So if PI test fails and IR test pass, it is safe to run the equipment. So the answer is it's impossible, I guess, because it's already past the IR, which IR is only 60 seconds. And if you do the PI, meaning you already consider the capacitive and absorption current, so that means you already have a good insulation there. Okay.
Okay, thank you, Michael. The next question is, on what test specimen can we apply PI and DAR tests?
This is a good question, Nito. Well, for me, when the temperature change is negligible, that is the best test specimen for PI and DAR. So let me give you example. If you have a cable that is submerged to water, will it be heated up? Maybe not, because it is submerged into water and the water is cold, right? So the temperature change is really negligible when you do the testing for this submerged cable. If this cable underground is submerged into water, so that is fairly temperature independent because the temperature change is almost negligible. Okay. If you have a cooling system, for example, in a transformer with cooling system, so the temperature is constant, almost constant, because we have this temperature control. So that's the best specimen for PI and DAR.
Okay. So the next question is, what's the difference between AC insulation testing and DC insulation testing?
Cool. Of course, when we do AC insulation testing, you are referring to most probably the tan delta test or the insulation power factor test. Well, they both have the same they both have advantage and disadvantage. So last webinar that was conducted by Joachim from Sweden, somebody also asked this one. So what he answered is, I will just repeat what he answered. If you do DC insulation, this is not bad. This is also good. However, if you do the DC testing in a transformer, for example, you need to consider the discharge. Okay? You need to consider the discharge because when we apply DC, you will have polarization. You will have this dipole aligned. So you need to do the discharge if you do the DC insulation. Now, if you do the AC insulation, this is better because this is better for the transformer. Huh? I'm not talking to everything, okay? Because motor, DC is much better than AC. So for AC insulation, and you are doing it in the transformer testing, this is better because you are looking, transformer is working with the AC environment. So if you are going to test that with AC, then you can clearly see how much capacitance, how much the inductance, or you can see the total impedance. Or you can assess the transformer with the actual impedance of the transformer. Okay, so there is advantage and there is also disadvantage of both, but they are both good in doing insulation assessment for, they are both good for insulation assessment. They are all doable. And the good thing with the DC insulation, it's, it's a cheaper and a faster way, while the AC insulation, of course, you need to, it's more complicated but more comprehensive test result. Okay.
Okay. There are two follow-up questions by Lito. He asked, how about motor, rotating machinery, and also this means to refer to the IEEE standard 43/1974. Michael, would you please answer the question?
How about motor and rotating machinery means refer to IEEE standard? What about the motor? Well, all I know about the motor, it's different. It has different what do you call that? Recommendation for testing the DAR, for example. In the motor, and if we're talking about the Baker way, they do the electric absorption at 3 minutes over 1 minute for the motor. Okay, so I'm not so familiar with the standard IEEE 43.1947, but maybe I can look it up nito, and I will give you some information about this.
Okay, so due to the time limit, we now accept the last 3 questions. Michael, are you okay?
Sure, no problem.
Okay, so first one is, what is the best next step if you get a low PI reading? Are additional tests required?
Actually, it depends. It depends on the result. So if it is less than 1, meaning it's just a flat curve, but it goes down. So that means after 10 minutes, you got more current. That is an indication of a really, really bad insulation. So remember the table that we have this assessment as good, up to questionable. So if it is questionable, then I recommend to do another test like AC insulation to confirm if the insulation is really good or bad. That's why they don't put it as a bad insulation. They put it just questionable, because if it happens that your reading falls under that ratio, then you need to do another test. But if it is really bad, then it is less than 1. So imagine if you could imagine, after 10 minutes, you still have more current, meaning you already let the charging current happen, you already let the absorption current happen, but still you have a high current. So that means that is really, really bad insulation. Maybe you have more moisture during the test. Or maybe it's raining during you conduct the test. Okay.
Okay. So the next question is, what is the consideration to do PI or DAR test?
That's sir. PI and DAR is why we do this. If we want a diagnostic testing, or if we have a large system that the change in temperature is negligible, meaning, for example, I got this large generator and then I shut it off, but still that generator is so hot, even if I waited for 10 minutes, it's not cooling down. So what we need to do, because again, if I tested that on a spot reading test, it may probably fail because it's so hot. That's why I need to do polarization and the electric absorption ratio, because that test is independent on temperature change. I am getting the ratio. Okay.
Okay. So the last question is, what should be AC voltage used if we use AC in place of DC voltage? For example, if DC is recommended voltage to be the 1000 volt, what should be the AC voltage?
Recommended AC voltage. Okay. For the test voltage, sir, you must know your equipment rating. You must know the voltage limit of your equipment, because like I've said, if you injected more than the rating one, then you can hear some sound, and maybe if it is really big voltage than the nameplate rating, then it will not be just an ordinary sound but a sound of explosion, so the best thing is, or the best way is, you should not exceed the equipment rated voltage. So if it is rated, for example, 10 kV, then you can inject up to 10 kV, but not to exceed 10 kV. Okay, because that is the rating of the equipment. So, and like I've said, if you do the DC insulation test, we have some sorry, we have some recommended test voltage according to the NETA table 100.1. So you can download it from the internet, so you will see the recommended test voltage. But of course, obviously, you don't have to exceed the rated voltage. That's the best way.
Okay, thank you, Michael. I think that's all the questions we got here. So thank you, Michael, for the presentation, and thank you everyone for attending. Just an announcement, we will have another upcoming webinar tomorrow. You can see the details in the chat box, which is on control and monitoring of transformer drawout process using DFR technology. And you will see the registration link. It will be tomorrow at 11:30 Hong Kong time. So if you are available, please join us in the webinar tomorrow, and we hope to see you again soon. Thank you, Michael, again. Yeah. Thank you, everyone, for attending.
Thank you, everyone, and hope to see you tomorrow. Tomorrow will be presented by our very own Dr. Diego Robalino. So he is the one of the experts of Megger. So better for you to attend that one.
Yes.
Thank you so much, Nito.
Yes. And don't forget to fill in the survey form before you close the webinar to give us some feedback. Thank you, everyone. Have a nice day.
Thank you, everyone. Have a nice day. Thank you, Grace. Thank you, Zoom. Thank you, Nito.
Thank you, Michael. Thank you, Nito. Thank you.